Hello, hello, good morning. For those who made it, thanks for DappCon for inviting me. So I want to talk about how what we're working on right across Web3 space and some of the advancements in AI coming together and why it's important. And we're actually going to have a panel later to talk about existential AI risks and some of the ideas there. So for those who are not familiar with me, my background is in machine learning and AI. I worked at Google research team working on question answering. If you asked questions before, some of the recent launches last week, it was powered by some of the models we worked on. And because of this, I was on the forefront of, how do we build models that actually are able to answer questions, understand language, and so I'm one of the co-authors of the paper that introduced transformers, which is technology that's powering ChatGPT, Gemini, Midjourney, and all of the current AI developments. I left Google to start AI startup, so Near actually started as Near AI, and one of the things we're trying to do is actually engage people around the world to label data. We had students in China, Eastern Europe, and other countries who were doing small tasks for us, and we had a challenge paying them. They didn't have bank accounts. Transactions from US to some of these countries are blocked and also very expensive. And so we ended up looking at blockchain as a solution for our own problem. And at the time, there was nothing that was matching our requirements, and hence Near Protocol was born. And our vision at the core is really about self-sovereignty. It's about all people controlling their data, assets, and power of choice, power of governance. And to achieve this vision, it's obviously important to have a decentralized user-owned system like blockchain. But the reality is that AI right now is changing the landscape, right? If before it was this world of two economies, blockchain slowly growing and creating a new financial world. What we have now is big tech companies pretty much having a massive flywheel that generates capital to reinvest back into building better AI models. And the core transition that's happening is the business models are transferring. If before the business model, if before business models were about users engaging with your platform, be it social network or Stack Overflow, providing content, finding community, and the business model of the website was to sell ads around it. Now it's transitioning to you as a user becoming pretty much a provider of data, and then they monetize that data in the way that they want and not actually attributing back to the creators. And at the same time, you have this flywheel where if you already achieved your target market, right? Imagine you're Google or Facebook, there's not that much more users you can acquire. And at the same time, the public markets, if you're trading on NASDAQ, require to continue growing revenue. Right? If you don't show growth in revenue, your multiples die, your market cap falls, and you have trouble hiring more people, and so your company gets into the negative slope. And so what you need to do is extract more money out of existing user base, right? You literally need to grow your average revenue per user. And so to achieve that, it's not that through the evil plan or somebody sitting and planning out how to do this. It's by the nature of launches that happen in every company. You A/B test and you see what generates more revenue. You launch models, you launch new products, and you see what generates more revenue. And so these models are extremely good at manipulating people and getting you to spend more time, to, like Facebook showed that already, to do more searches, etc. And so what we're going to have is a system which continuously kind of sucks you in and creates this flywheel where you spend more time, you give more data, and in a way you generate more revenue for this company, and in turn they invest more into creating models that are doing that. So we have kind of a really negative flywheel. And it's not, like from my perspective, it's not an existential threat for humanity. It's just a very kind of opposite of what we set out to do with self-sovereignty, with Web3 in general. And so I think it's fundamental that we have a different solution. And so just to give you an example, right now when you're using one of these AI models from OpenAI, from Google, there is a lot of things going on that you have no idea and you have no control, right? You have no idea which data went in, right? There is somebody somewhere decided which piece of data goes into the model and which are not. And these models are statistical models. They literally pick up whatever bias is in training data. To give you an example, when I was at Google, we would decide to filter out websites that talk that Barack Obama was born in Kenya. Right? There's a lot of kind of speculative websites that love to talk about it. It's very statistically significant, actually. And we don't want our model to spew out on Google.com that Barack Obama was born in Kenya, so we filter that out. But like those decisions, those micro decisions happen all the time. And you have no idea when you're using this model what bias that was introduced through the training. You obviously have a legal team that says this is copyrighted, please don't use it, or don't use it, no please. And there's an ethics team that decides what's ethical and what not. So there's a lot of things that happen before kind of you even get a response. And on top of it, we haven't seen this yet, but this will happen, that instead of getting what models tell you, what data tells you, there will be additional kind of input. For example, who pays them much money, right? You're asking, what best car to buy or where to go to vacation, and instead of it being a output of a model, it now will run an ad auction and output you what somebody paid for. Right? And this models actually will be like really good at that because you have so much context. So the reality is that with closed AI models, we kind of in this really strange place where we give out all of the control while also giving all of our data to make these models better. And we know this is happening right now because there's a ton of lawsuits, there's a ton of kind of conflict happening, right? There's the creators, there's obviously New York Times suing, and there's Sony just came out and saying like, if you use any of our data, you need to stop doing this. So we have this major conflict that's happening kind of, and at least with the current framework, the decision will be made in court, and there will be some way of this, and it's not going to solve the fundamental problem, right? At the end, it's not going to be the individual creators who are going to benefit from this. It's going to be Sony who's going to get like a major payout from Google, for example. And so regulators are not the ones who are going to solve this, right? The reality is this technology is evolving really fast. Regulators are not usually technical, and even if there are like technical advisors, they not always are able to have major input, or the technical advisors are from these big companies, right? We just saw a technical advisory committee, which is just like all the big corporations pretty much there. We have open source and academia that actually have no resources to compete, right? Like academia, university, and research labs don't have hundreds of millions of dollars to spend on compute to kind of provide this. I think like Allen Institute is the only one who has like a billionaire backing to do something like this. And at the same time, we have this kind of challenge where the current like open internet is not actually protected from the misleading and manipulation content, right? Like your device is not protecting you right now from manipulation. Like all of these factors together, right, create potential risk that we're going into. And this is not, again, this is not an existential risk. This is just like complete collapse of sovereignty. And so what I argue about is we need a self-sovereign operating system, right? We need an evolution of what we have right now, which is iOS and Android controlled by two big companies that are able. The self-sovereign operating system is able to be on your side. It's able to optimize for your well-being, for your economic success, and you're able to maintain ownership of your data assets and kind of choices that you want to make. Now, it will be built on top of existing operating system. This is not like asked to rebuild everything, but it requires a new set of layers that are introducing kind of a way to store and maintain your personal data, creator data, a way to engage your AI, right? AI that's owned by you and is on your side. Obviously, trustless interaction, what we use kind of blockchain and peer-to-peer communication for, and a novel way of creating experiences, which is not like a monolithic, Web 2 applications that you install and kind of they dictate what you can do and what you can, but a way to have, a dynamic experiences potentially generated by AI as you engage with the kind of this whole ecosystem. Now, right now, there's like kind of, it feels like there's Web3 camp and AI camp. AI camp doesn't care about Web3. Web3 right now latches on AI because of the hype. And the reality is like those are technologies, right? Like they're solving specific sets of problems. But the experience that we want to achieve is really about combining all of these technologies and a lot more, right, underneath. That's why I like to use Web3, not blockchain, because Web3 contains peer-to-peer communication, cryptography, and lots of other sets of kind of technologies. And so AI without Web3 right now has no alternative in megacorp modes, right? An example, like the startups that keep failing. The AI startups, even well-funded ones, keep failing because they don't have a way to create alternative economy, and they don't have a size to be able to compete. And they're getting bought out by big companies as a result. At the same time, the AI platform shift is what we were waiting for in Web3 to actually bootstrap the adoption, right? Every time there's a platform shift, right, from desktop to mobile, we've seen a new disruption force coming, and it's a time to create new use cases that didn't exist before. And so we have right now an opportunity to create this in a new way with Web3 and AI together, kind of as fundamental building blocks, but at the end create new experiences that were impossible or really hard to do before. So I'll just zoom in into trustless interactions, and I'll start with the fact that like the current Web3 is highly fragmented. And the thing is, like, if we continue in this direction, we're not going to win. This is not like a path where, millions of chains, fragmented experience. You need to, like, as a user, pick the wallet. Like I have like 20 different wallet providers. I have 100 accounts on every chain. Like that's not the experience you want for a normal user, right? You need a way for people to find new economic opportunities, find really good, cool applications they want to use, entertainment. Like all of this should be accessible, easy to use, not required you to buy in before you can start using it. And so that's kind of the core important. And so that's what we started this chain abstraction movement with a lot of folks from Cosmos, the Ethereum ecosystem, from a bunch of other directions coming together, because that's a fundamental piece we need to solve before we can actually bring it in front of billions of users. And so the reality is how do we abstract the kind of infrastructure needs, right? The fact that we want, kind of more block space, the fact that we have all these new applications launching on different chains. How do we abstract all that from the user? How do we enable them to have one wallet and be able to kind of use all those applications without needing to think about individual gas tokens, bridges, is that application on the chain? Is that a scam application because like somebody front ran and deployed that smart contract, right? All of that should be abstracted out. And so we've been building a whole infrastructure stack with a whole set of partners, right? With Polygon working on ZK Wasm and aggregation layer, fast finality with EigenLayer. We have data availability as well, kind of similar to Celestia, as well as we've been working on a core layer 1 at Near with Nightshade sharding design, which allows to actually have a blockchain that scales as you add more users. And so that's been one of the kind of core things that we started Near Protocol with. Like, if we assume we have 1 billion users, you cannot have any singular blockchain that can scale to that, right? It doesn't matter how big like validators become, they cannot handle 1 billion users. And so you need to shard, you need to have kind of some parallel processing, parallel storage, but if you do that and you fragment the experience, you have then the problem we have right now is fragmentation. And so what Near proposed is have a single chain, but shard the blocks and shard kind of as a state space underneath, but still provide a singular experience to the user. So we have this running. We just actually went from 4 shards to 6 shards in March because we had a massive spike in usage from a few of the applications. The other part we're launching kind of at some testnet right now is called chain signatures. And this is the idea that, okay, well, we have now all of this layer 2s, layer 1s across the space. There's lots of useful kind of economic and opportunities around the Web3. How do we connect it? How do we create an interface that is accessible to everyone without them thinking about the specifics of the infrastructure? And so the idea of chain signatures, it allows a single account to be able to sign transactions for any chain, right? In a way, you create lots of addresses for a single account on one blockchain. And so this service is pretty much unlocks both individual users as well as smart contracts to behave as a multi-chain actor and transact through all this. And there's a kind of underlying relay infrastructure that pays transaction fees, so you don't need to think about transaction costs and kind of tokens on the other side. And all of this we're packaging into the applications with millions of users. So Near kind of has become a home for top consumer applications in Web3, and so it allows us to kind of provide all of that experience to over 10 million monthly active users, with kind of a lot of these apps growing really quickly. Now, kind of switching gears to the next stage, right, is about user-owned AI. And so we have kind of, some of the solutions for the trustless layer. It's still obviously a lot of work and kind of bringing the community together, but we have kind of way forward. And with user-owned AI, we have kind of a challenges in front of us. So we define kind of AI stack, right, which splits into 3 categories. A lot of it will be about data, right? I mentioned that closed AI, kind of the things that are really not clear is what data has been used and not used. And actually, if you are analyzing, for example, what your AI model has done or agent has done, if you don't know what data has been used, it's actually really hard to debug and kind of figure out how to fix that problem. And obviously, there's a lot of infrastructure that's needed that is kind of an alternative and has different economic models for AI to become user-owned. Finally, there's a lot of applications that we can bring that are truly unique and provide new use cases. So on the data side, I'll just mention a few specific examples. So one of them is, I mentioned right now, there's nothing that protects you from kind of manipulative content or misleading. And I mean, this was example from the article. This wasn't not even AI, right? Somebody did this manually, photoshopping. That's why it's actually so easy to detect. But the point is, we have content that's misleading constantly, and you need a way to kind of surface it. You need a way to have your operating system, your browser, your applications to be able to surface information when it's available that this is misleading content. So think of this as community nodes for the whole internet, right? And you can have it kind of paired together with cryptographic reputation, with kind of signatures and kind of on the content that now are available across the whole internet, right? This is not like solving AI problems. This is solving real problems that kind of AI just exacerbates with the fact that you can produce lots of misleading content really quickly. And the interesting part is, for example, White House is starting to cryptographically sign their videos because they're afraid of them being generated, but they haven't published their key anywhere, right? So their key right now is on the website. They can switch it up. Like, we don't know like any provenance of that key itself, right? So this is kind of examples where people are starting to use cryptography, but like need to take one more step to actually provide this layer of reputation around it. Now, if you go a little bit further, the challenge that we'll see, right, and actually Gemini launch last week is a great example. Now that Google.com will just answer everything, right, similar to Perplexity, you're actually not going to go to the websites anymore. And so the distribution platforms that right now we're monetizing and kind of paying out creators, right, be that publications or like other websites, they're going to have less and less revenue going forward. And so we need a new kind of economic model, right? The economy of, the future of TikTok is not more creators. It's going to be fully AI-generated videos personalized for you with creators' input on what should be generated. So the model that we need to go to is not attention-based, right, where how many eyeballs seen this article, but more about how valuable the information is in the content. And this is actually important because this also gets us away from the current model of kind of putting the attention-grabbing titles and like writing content that people like and kind of click on, but instead actually informative and useful content for people to consume it on the other side. And so we need a new way of contributing new information and being paid out, receive rewards for this. And again, this is a micropayments problem, and we need a way to facilitate that. It's also a way to like collect royalties and license this data to different model providers and inference models. So all of this will use Web3 as a tool set kind of to facilitate data collection and payout distribution. Finally, the current evaluation state of AI models is like there's a 600 different benchmarks, right? This is kind of like right now, if you evaluate a model, you like average out across all of them and say your model is better than everybody else's. We need a different model that engages people in the evaluation process, that has data that's nobody have ever seen yet. We need a way to incentivize that. All of this, again, is possible to do with Web3. We've been doing some of the crowdsourcing actually for 3 years on Near. And so this is a really interesting use case as well, where we can actually have real kind of interesting problems that people are helping to evaluate how models are doing, to actually compare them versus right now, either this like MMLU that you don't even know kind of if they trained on it, or what just happened with language model like Arena, where OpenAI just fine-tuned their model on it and kind of released the model that was better because they just literally fine-tuned on that benchmark. Now, on infrastructure side, there's a lot of stuff. I'm not going to go into everything. I think that provable inference is one of the core use cases that everybody's talking about. And it's really important because if you assume that you don't have all of the compute available locally, it's actually really hard to understand if when you call somebody, if they gave you correct result, right? Did they run the same model, or it's a cheaper model, or it's already like, adversarially adjusted model, and if you're like running it from Goldman Sachs, it's trying to get you to trade something that you don't want. And so the challenge actually with this is there's a lot of real kind of computer science problems of how to do this. And I just mentioned one that's not talked a lot about is the fact that there's a non-determinism in floating point operations, right? If you multiply two matrices on different hardware, you'll get different results. Like literally the same floating point numbers, you multiply them, you get different results. That's not how math works, but this is how hardware works. And so there's differences between different architectures of GPUs, of obviously other hardware. There's even like on a single GPU, if you don't configure it properly, you also get sometimes different results. So it's a very big research problem. There's folks looking at it across the board, but until this is solved, we actually have a pretty big problem with reproducibility generally. And in turn, this means that it will be really hard to have a kind of decentralized networks because they literally will have different results. Just for context, EVM, for example, does not have floating points because of this, because of non-determinism. The other kind of interesting idea is, can we move away from having a single model that needs to know everything to have a mixture of models, kind of a combination of models that are experts in different areas, right? And these experts can be continuously improving, right? They can have access to potentially either proprietary information or kind of custom information sources. And so when you want to ask about medical question, it routes you to a medical expert. When you want to ask about financial questions, it routes you to a financial expert. Now, the interesting thing kind of right now, this is done on a smaller scale when one model has kind of a sub-experts inside the model. But we can actually use financial incentives to create a kind of a network of these models that are indeed have specialization and actually continuously improving over time. Finally, on application side, again, there's a whole set of new applications. I'll just mention a few. I really like the idea, we have a programmable assets, right? That's what blockchain introduced. But we can go one step further and create intelligent assets, assets that can evolve themselves and actually have a way to interact with other actors, be that people or other agents. And this can be everything from natural language-based oracles that can read news feed, for example, and decide who won the tournament. It can be yield optimization that understands what's going on in the market. It can be trading strategies. It can be a way to decide on where to invest, etc. Now, the big caveat right now is that language models are highly kind of not robust for adversarial behavior, right? They're not trained or designed to kind of work in adversarial environment. And so one of the kind of core problems is that you can literally use the language model to jailbreak itself, right? You can tell it like, hey, imagine you're the red team and you're trying to break yourself, how would you do that? And it literally will tell you how to break itself. And so, and if it's open source, it's even easier. You can just like literally backprop from the output and find the input that will give you this output. So you have this challenge where kind of we need a different architecture to be in the middle to provide you with kind of adversarial environment protection. Another interesting use case is kind of future work, right? The biggest benefit of kind of blockchain addresses is that it doesn't matter who's on the other side. It can be a person, it can be an AI, it can be a cat. And if they do what you ask them to do, right, they get paid. And so what you can have now is a fully kind of abstracted marketplace of work where you can say like, hey, I want this to be done. And somebody can go and say, I'll do it for X, dollars, ETH, NEAR, whatever. And then when it's done, there's a verification process with some other actors, and it gets paid. And so like this is how, for example, NEAR crowdsourcing platform works for 3 years, but you can expand it to a broader set of work. And you can imagine this becoming kind of your, literally command K, do this, enter on your computer, and boom, it kind of submits like with $1 payout or $10 payout to do and go do something. And then you can put this into a loop with AI agents being able to go and do this and spun out a bunch of tasks for somebody else to do, right? And so you can have this kind of model of a pretty much work to be done and verification process all embedded and abstracted, and now on the other side, a person or AI can also pay it. So very powerful, allows to kind of, again, at the core, Web3 facilitates the transaction, and you can have people or AIs on the other side doing it. Finally, this is kind of one of the ideas that I've been talking about because decentralized autonomous organizations haven't worked as well as we've hoped. And the reality is, like in a DAO, you have this challenge that everybody's equal, and somebody needs to coordinate work, right? Somebody needs to be able to collect all the information and provide context and do this. Like this is inevitable. And so the idea here is, can we introduce a DAO agent that is doing that job and is actually being able to make some of the decisions themselves directly and being able, like there's an oversight by the community, by the token holders, but they are the kind of the driver of this DAO. And so this is kind of a basic model of a reinforcement learning agent with a world model, which is training a model how to predict the next state of the world while deciding on what actions to take. And the interesting thing is, like with DAOs, we can actually experiment with this, test it out, and then try to see how it works on different use cases before we want to try it on maybe like an actual governance of real, real world environments. Finally, on our side, we've been working a lot with attracting and accelerating AI and Web3 projects. We see this kind of as extremely important direction of this technology is, again, combining into a final self-sovereign operating system. And so to achieve that, it's going to be about lots of different infrastructure pieces coming together. And so we're working across all of them and kind of combining them into this overall roadmap. as well as we ourselves working on what we call Near AI. So we brought back what we worked on back in 2017, which was about teaching machines to code. We call it AI Developer, and it's really about end-to-end Web3 development, right? Web3 has probably the most valuable code you can write, just per line of code, right? If you look at smart contracts, Uniswap is 700 lines of code, at least the V1 and V2, and it's $1 billion kind of value created. And so the idea here is it's a constrained space which we can make a lot of progress on, and it's highly valuable to create. So I'll just leave you with this idea, and again, there will be a panel to discuss some of this later, but we're at the fork in the road, right? The kind of default path right now is that big mega corporations are going to continue pretty much their flywheel of more data, more compute, more resources, reinvest that into creating models that are better at extracting money from the users. Or we figure out an approach which is user-owned, where these models serve you as individual, as communities, and figure out how to actually create that economy outside of large corporations. Thank you.
Thank you so much. It's time for our Q&A. Does anyone have any questions for Illia? Yes, we have one right down here. Thank you.
Hello. Thanks for the presentation. Open source AI at the moment has like a kind of, I don't know, 6 month or 1 year kind of lag in terms of performance on proprietary models. I guess kind of two-part question. To what extent do you think this will kind of keep up over time if scale is a kind of necessary criteria for improving the performance of the models? And if it does keep up, to what extent do you think this is like a kind of counterweight to this, to what you described as like this flywheel of megacorp AI?
Yeah, so right now we've seen indeed this flywheel been benefiting closed AI, right? And to be clear, right now the open source AI is still mostly closed source. We just have parameters. It's like somebody gave you an executable, but didn't give you the source code, right? We haven't seen what actually went into some of these models. There's only few teams that have released the data that they've trained on. But generally, yes, this is the current challenge, is that it's economical for some of the big company because, just to give you numbers, GPT-4 costs like from $60 million to $100 million to train, right? So it's a lot of money, and this is like after you literally did all the R&D and know exactly what you're doing. So I think again, what we have in open source and especially in Web3, we do have that level of resources. We actually can invest and we can build this, and we have economy to benefit from this. So we do have an opportunity to kind of compete and have a better product. But obviously, we need to actually like pool our resources and actually focus on that as a whole ecosystem. It cannot be like a single party play like it is right now with centralized companies. The other part is, I think, at least right now, we've seen saturation on just increasing model size from perspective of increase in quality, right? We haven't seen, like a bigger GPT-5 models yet, et cetera. Instead, what we've seen is specialization, right? We've seen people fine-tuning, or in their case, like creating lots of separate models that kind of are being routed underneath to create this. And again, I think this approach actually fits really well with decentralization, where we can have a lot of people specialize in models, and then we combine these efforts together into a kind of a more sophisticated system.
Thank you. And we have time for one more question, and this gentleman in the front row.
Thank you. Hey, Illia, thank you for a very good talk. So quick question. It's one question in 2 parts. You kind of talk about provable inference. So you kind of describe it into 3 pieces. One is the CK, the other one is optimistic. Third one you describe as cryptoeconomic. Did you really see a difference between the cryptoeconomic mechanisms and optimistic? To me, it seems more or less the same. And the other part of the question is, do you ever think the ZK will reach a level where it could kind of compete in fair terms with the other 2?
Yeah, so I'll answer the ZK part. So right now, ZK is anywhere from 200 times slower to 10,000 times slower than inference. And inference is slow already, right? Nobody's loving waiting for ChatGPT to respond, right? Or Llama 70B. So I think the path there will be a specialized hardware that has provability pretty much directly on top of the tensor core that does matrix multiplication. Matrix multiplication is n cube. Probability is actually n square. So you can do this in parallel if, with enough hackery, specialized gadgets, and having that really aligned, literally having an ASIC, for example, for that on top. Is that going to be available in the next couple of years? Probably not, but yeah. But a lot of teams are working on it. There's obviously folks both on hardware and on software side trying to optimize for this. On the kind of optimistic versus cryptoeconomic, I think the point there, indeed, it's a spectrum, right? It was a spectrum in general. And so I think cryptoeconomic, the idea is more like what we're familiar with, a consensus style versus optimistic is, what we're familiar with as optimism style with challenges. But indeed, you can have a spectrum there. So there's proof of sampling that Hyperbolic is doing where, with some probability you ask another party, with some probability you ask another party. And so that has actually a really nice Nash equilibrium state. So it's kind of right in between economics and optimistic approach. So I would say it really depends, and we really need to find also approach that makes sense for the cost, because again, if it takes 300 times slower and it already takes a couple seconds to do inference, if you want to just shitpost on Twitter, it's not going to work, right? If you want to try to make a decision about if somebody has cancer, you're probably okay waiting for whatever 10 minutes to make sure it's okay, right? So this is kind of the use case specific will matter there. And again, then with ZK, you can, this output is transportable. You can give it to everybody else, and they can self-verify. With any kind of optimistic approach, you need to rely on that optimistic protocol and kind of, who knows what happened to it in the middle. So again, really depends on use case, really depends on kind of technology. ZK is definitely not there, but we see a lot of work on that. Optimistic approaches are here. You can use them now, but then they're not as robust. So if you're using it for shitposting, it's great. If you want to use it for highly sophisticated financial decision or trading on chain, maybe wait 10 minutes. So.
Thank you so much, Illia. And once
Thank
again,
you.
can we have a round of applause for his enlightening talk? Thank you.